We're in Madison, Wisconsin. This is where most of our platform development happens in manufacturing. I'm responsible for product development, so for the entire life cycle of advanced development, new product development, sustaining engineering, product retirement for the engineering part of delivery systems. I have been at Accuray for almost 4 years now. Oh, I love making product. I love solving problems, and it's always better if you can also help in what we're doing, curing cancer. We treat cancer in two very specific ways. One is planning to get the right dose delivered to the patient, and then we deliver very precisely that dose. So on the planning side, it's helping the radiation oncologist determine exactly where that radiation is to go, and most importantly, where it isn't to go. We don't want to hurt good tissue. Once we have that, then the delivery system, the other side of the business, is the machine that actually precisely points that radiation to the target. And so therefore, the best chance of curing that cancer and not destroying good tissue. We're extending our product line in motion synchronization. We are driving more and more 3D imaging into our platforms. We are continually, we are improving our reliability. We're driving cost out. We are excited about motion synchronization for the same reason we had just talked about, right? It increases the planning accuracy. The body moves, things move. And the more we can freeze that movement, then there's a better chance for us to deliver the radiation to only where we want it to be delivered. The team is very excited about motion synchronization for two reasons. One is obviously the benefits to the treatment and the precision. The other is it's a complex problem to solve. Engineers love to solve problems, and this is the most complex technical problem I have solved in my career or been part of. So. Engineers are just as excited about the technical problem to solve. This is the most complex technical development I've been in my whole career. This involves every discipline of engineering to do this: physics, electrical engineering, mechanical engineering, software. So engineering get excited about that as well. One of the most significant milestones since I've been here is the release of the Precision platform and the radiotherapic platform. So not only is it with what those platforms deliver, but it's about the future capability of those platforms, such as motion synchronization and 3D imaging. Other developments is what we've done in improving the reliability and the cost position of our product. My team is delivery systems, and that's about 90 people over 3 locations in Madison, Sunnyvale, and Cleveland, Ohio. So the makeup of those teams, all the engineering disciplines are represented in this business. Physics, electrical engineering, mechanical engineering, many types of software engineering from GUI to embedded systems, reconstruction engineers, algorithm development. It's almost every engineering discipline is represented in the development of our products. The most significant new product developments we have right now is the motion synchronization projects, 3D imaging on both platforms. So that's, again, the 3D CT image of the body on board of the system. My typical day, it usually starts with field-facing things first. Anything associated with an existing customer to ensure that our customers in the field are happy. Machines aren't down, customer satisfaction's high. Then it's on to the new product development that we have going, and I'll be part of reviews to ensure that these things happen on time with quality. My proudest moment at Accuray is the release of the radiotherapic product. And especially the last phases, hitting all those phases absolutely on time and keeping the quality bar at the highest it's ever been. We released with far less defects than we ever did before, and it rolled out very smoothly in the field. Very proud of that, of our team and that initiative. So one anecdote I can share is I was in here on a Sunday night, 5 p.m., giving a tour for somebody, and I heard somebody in the lab, didn't expect to see anybody there at that time. So I asked the technician, what brings you here at this late night, at this time? And he says, we have a deadline, we have to get this product out. And that's when I knew for sure this team was fully invested in the plan and in getting it done. We work with users in many ways to get the product design right. So in the beginning, we work very closely with our users with either luminaries or through surveys or direct contact at trade shows or visits to ensure we have the requirements right for the product we are building. Once you've built the product, it's hard to go back and get it right. So we like to involve our users earlier and earlier in the process. I mean, right down to literally reading our requirements with us to ensure that we have them before the engineers go off and develop. Then we work with users on the back end when we're ready to release the product, to have them validate the product, to ensure that what we've designed actually met their needs. Then lastly, after we've released the product and it's in the field, we survey, right? And we measure, what is going well, what isn't going well, and we'll use that to adjust and feed our requirements back into the next release. Innovation means a lot of things. Innovation could be new products, new features. Innovation could also be how to drive cost out of the product. It's just as important of an invention to get 15–20% cost out or double our reliability as it is to do motion synchronization. So we invest in that. We invest in advanced development. And 15–20% of our time sometimes is investing in those, in seeding those product developments for the next year or 5 years from now.